Hello and welcome to Train Signal. This is video number 3, Introduction to and Management of ISA Server. Here's our table of contents for this video. First, you'll be given an introduction to ISA Server concepts. We'll have an overview of ISA Server features. We'll look at what you should initially configure on a new ISA server. We'll review the management of an ISA server. We'll look at the importance of Windows Active Directory in terms of ISA. You'll learn about remote management of ISA, and then we'll talk about hardening the default ISA server installation. First off, let's look at an introduction to ISA server concepts. ISA server is part of Defense in Depth or Security in Layers that we've talked about before. This means that ISA server is just one part of your security infrastructure. It's not an end-all, it's not the silver bullet that's going to totally secure your network, but it's an important part and it goes a long way to securing your network. Securing your network is a continual process, meaning you're never done securing your network. It's not something you do and then it's over. Securing your network is a continual, never-ending process that you have to constantly maintain, test, update, test again, and maintain, and it just goes on forever. ISA is used to secure the perimeter of your network primarily, but today that perimeter can be difficult to define. In the old days, years ago, a small company or even a large company might have just one internet connection and they used it for web browsing and email, and that was it. Well, today you've got VPN tunnels, you've got remote access VPN users. On the other side of site-to-site VPN tunnels, you have other sites. You might have many sites connecting through the internet with site-to-site VPN tunnels. You might have business partners that you connect to over the internet, using some security protocol. So defining exactly where the network ends and begins can be very difficult. Basically, ISA is a firewall. ISA is a firewall. That's its primary job, is to be a firewall and to protect the perimeter of your network. To do this, ISA uses packet filtering, stateful inspection or stateful filtering, and application layer filtering. Now, packet filtering is what you typically think of when you think of a firewall. You have these rules on a firewall. The rule says permit traffic from this IP address to this IP address only if it's TCP and only if it's port 80. Then the firewall rule says deny any IP packets from this network that use UDP on port 5000. So these are examples of firewall rules, and that's typically what you think of when you think of packet filtering. That's what packet filtering does, and that's what ISA does. So it performs packet filtering. Next, it performs stateful filtering. Stateful filtering means it looks at the TCP header, and in the TCP header information there are different states. States of TCP might be SYN, FIN, ACK. There's a number of different states of TCP. TCP is a stateful protocol, meaning it creates a connection from one computer to another computer. It transfers data, and then when it's done, it disconnects. So think of it much like a phone call. When you make a phone call, you pick up the phone, you dial, the other party answers, they say hello, you say hello, you have a conversation. When you're done, you say goodbye, and they say goodbye, and you hang up. So TCP has that connection between the hosts. And because that connection is predictable, the firewall, ISA in this case, can monitor that connection, and it would know if something strange happened. For instance, hopefully your phone doesn't just have someone there all of a sudden without it ever ringing. Your phone's going to ring, you're going to pick it up, say hello, and then the other person's going to say hello. It's very predictable. You should never pick up your phone and instead of a dial tone, just have someone on the other line. Just the same, your phone should never just start talking with someone else's voice without you ever answering it and saying hello. So TCP states are monitored by the firewall, and the firewall knows if something weird happens. The last thing that ISA does to act as a firewall is it does application layer filtering. Application layer filtering means it understands how the applications work, and it can filter data based on how the applications work. So it knows that HTTP uses certain methods to transmit HTTP web pages. It uses a certain method to upload data to a server and download data. Just the same, FTP uses, say, a GET and a PUT to transfer data up and down. So because it understands how the applications work, it can filter on those applications. So with FTP, it can say you can do a GET but not a PUT. So meaning you can download a file using FTP, but you can't upload a file using FTP. Whereas most firewalls today don't offer application layer filtering, ISA does. So application layer filtering is relatively unique when it comes to firewalls. It's relatively new, and not a lot of firewalls offer it. So ISA is unique in that area. So ISA can monitor the FTP connection and allow you to download something but not upload something. So that's ISA server concepts. Now let's have an overview of ISA server features. ISA provides secure internet access. That means it can filter and understand traffic based on users, based on the website, based on a protocol. It can log all requests, and there's no direct connection to the internet by the client. So picture you having a user at your medium-sized company connecting to the ISA server to make a web request out to the internet. The internet never sees the private IP address that's on the inside. That's due to network address translation that the ISA server is doing. So it's translating the private IP address to a real public IP address, and that public IP address is the IP address of the ISA server. So it might look like your ISA server has 1,000 different web requests going out to the internet at one time. That's from those 1,000 different users. So the source of all that traffic is the ISA server. The ISA server knows the names of every user accessing the internet, making those requests. It can filter the traffic based on IP address, subnet, a particular website, a particular domain. It can filter based on protocol, meaning this user, John Doe, can only go to this website and can only download FTP files. That's all they can do, and it's going to log all the requests every time they make a request to that particular website to download an FTP file. It's going to log it. Anytime they try to go to some other website, or anytime they try to upload an FTP file, ISA will log it. So ISA performs all these different functions to provide secure internet access to a company's users. ISA allows you to securely publish internal resources with application content filters. So picture your company having an email server or a web server. You provide those. You want to provide those to users out on the internet. You know, your email server needs to be able to send mail from your users out to the internet. Just the same, it needs to be able to receive mail. Your web server needs to be able to be accessed by external users out on the internet. So it's dangerous to put those servers directly on the internet and have full internet access without any sort of protection. So what ISA can do is to protect those devices. ISA can only allow, say, SMTP traffic to come into your server from the internet. That's it. No other traffic could come to your server from the internet if that's the rule you choose to create. Just the same, ISA can take that SMTP traffic. It knows the protocol. It knows the predictability of SMTP, and it can filter that traffic and make sure that no weird requests come through that wouldn't be normal SMTP requests. It can also filter SMTP mail. It understands Outlook Web Access. That's the OWA right here. Outlook Web Access. This is Exchange's web-based email application. It understands OMA, Outlook Mobile Access. This is Exchange's mobile interface for users with web-based phones and web-based PDAs to access their emails. It understands these types of applications, and it knows how they should work and what type of commands and requests should come from those applications normally, and it can filter that traffic. So it would protect your OWA server, your OMA server, and you could put those on a DMZ, a secure network interface right off of the ISA server, and the ISA server would protect those types of servers. ISA provides VPN access. So it can do this in two different ways. The first is remote access VPN. So say you're at home, you want to connect into your work network, you use a VPN client built into Microsoft Windows, you connect to the ISA server, and you're put on the private network. So it's just like you're working from your own internal office, but really you're out on the internet. So you're providing remote access VPN services from your ISA server. ISA can also provide site-to-site VPN services. So say you have 10 remote branch offices, they all have internet access. You can put an ISA server at every one of those and create a fully meshed site-to-site network between all those locations using ISA through the internet. Another service that ISA can provide is web caching. So web caching is you have internal users, they're making web requests to the internet. Say everyone's trying to get to trainsignal.com. There's 1,000 users on your internal network. They hit that website many times a day. Well, instead of using up your valuable internet web bandwidth, ISA can cache the data from that website. And when the first person requests it, it saves all those web pages and graphics. When the second person requests it, and from then on out, all the other users that request it, ISA provides that web page and those graphics to those users immediately without having to go out to the internet and pull it down again. So those users are going to get it faster, and you're going to save on bandwidth because ISA is providing that web page to them immediately right off the hard drive on the ISA server. Another thing ISA can do is offer basic intrusion detection right off of the ISA server. So this is enabled by default. ISA can detect basic types of intrusions to the ISA server, and it can alert on those. It can perform DNS filtering and alert on DNS attacks. Also, numerous ISA add-ins are available. So you can go out to the internet and you can download all sorts of different add-ins for ISA. A great add-in for ISA for web download filtering is one called Download Security by GFI. What this add-in can do is it can filter all downloads in HTTP that a user might try to download from the internet. It can filter those, and it can quarantine them, so it can put them on the hard drive of the ISA server so the user can't get them. And then you can go and review those downloads and provide them to the user. It can also filter them for viruses, so it could provide the download to the user only if it doesn't have a virus. There's a number of other add-ins for ISA, and a lot of them are very worthwhile, and a lot of great ones out there. So with that, let's move on to the initial configuration of ISA. When you're creating a new ISA server, what you need to initially configure can be a little blurred sometimes, and that's because there's so many different deployment scenarios. You could use ISA just as a firewall, you could use it as a web proxy, you could use it for web caching, you can use it for VPN access. It can do so many different things, so what you need to initially configure really varies depending on what you're going to do with it. But one thing I want to point out is that no traffic is allowed by default. So ISA is a firewall, so when you first turn it on and install the software, there's not going to be any traffic that's going to be allowed to come in or go out of the ISA server. So it's not like a little DSL router at your house that by default, allows everything out. Even though some of those little DSL routers say they're stateful firewalls, and they are stateful firewalls, by default they're not very secure. So common initial tasks are to create networks. Now a network is what ISA uses to know what's the external, what's internal, and what's, say, a DMZ network. So ISA has to know basically what is the public network that I'm protecting the internal users from, what is the internal network, and what's the semi-secured network like the DMZ. So you might want to define that. Now by default, the external and the internal network are already created. So unless you have a DMZ, normally you don't have to define that. Creating firewall policies. This is what you're going to do most of the time. This is the most common task on ISA server, is creating a firewall policy. Basically, a firewall policy is just a rule that says, this type of traffic can go out, and it's based on, where's it coming from, where it's going to, the protocol, the user. Could be a number of other things that you can create these firewall policies on. So essentially, these are rules. Okay, define web caching policies. ISA server, if you're using it for web proxy, it can also cache websites. So if there's some common website that a lot of users go to, you can define caching rules. So that might be something you do. Configure VPN access. If you're using it for remote access or site-to-site, that's probably something you're going to do. And then enable client connection methods. If you want to use the firewall client or the web proxy client, or if you're going to use Secure NAT, you need to decide, and you need to enable some of those. Secure NAT, for instance, is on by default. You just have to create a rule to allow the traffic out, and your clients have to have their default gateway pointing to ISA. Web proxy, on the other hand, you have to go in and enable and set the port number. So various client connection methods you may want to configure. With that, let's move on to the management of ISA server. There's a few different ways to manage ISA server. One is to use the ISA server management console, the MMC, and I'm going to demonstrate that in just a second. But I also want to point out that ISA server performance monitor is available. And here's the breakdown of what the ISA management console can show you. Now let's go look at this, because seeing it is worth so much more than just talking about it on a list. So with that, I'm going to minimize that. I'm going to go over to remote desktop, and I'm going to connect to our ISA server. So I'm going to go down here to Start, All Programs, and Microsoft ISA Server. And here's the ISA Server Management Console I talked about. And then here's the ISA Server Performance Monitor. So both of these are available. Obviously, most of the time you're going to spend in here in the Management Console. So let's go in there. So this is the ISA Management Console here, and this is an MMC. It's a Microsoft's management console, and MMCs are used, to manage just about everything in the Windows operating system today. So here's our ISA server. I'm going to expand that and expand the configuration. So these are the different pieces that I was talking about over here. Let's go back and look at the list. So the management console is broken down into monitoring, firewall policy, and virtual private networks. Let's look at that. Monitoring, firewall policy, and virtual private networks. So if we click on monitoring, here's all the different things we can monitor here. So this is used to obviously check the status of the ISA server. A lot of different things you can monitor here. You can configure alerts even, sessions, services. reports, various things you can monitor. Firewall policy. This is where you create the rules that you tell ISA server what's allowed out of the ISA server. This is also where you publish services to come into the ISA server. Could be a web server, mail server. And then you also define system policies here. System policies are connections made directly to the ISA server. These are usually for management of the ISA server. And then virtual private networks. This is where you enable and configure virtual private network access. Could be remote access VPN, or it could be a site-to-site VPN. Then here's the configuration section down here. Let's look back at our list here. So configuration has network, cache, add-ins, and general. Let's see that. So networks. Here's where we define our networks. So right now we have an external network defined and an internal network. We don't have a DMZ. We have localhost, quarantine VPN clients, and VPN clients. But there's really no IP addresses on those right now. And there's a little diagram here that shows what our network looks like right now. Cache, this is where you define web caching. Add-ins. These are add-ins that are already in ISA, but if you were to install some other add-ins into ISA, sometimes they will appear in here. Sometimes they have their own management and configuration program. And then here's general. General has a lot of different things in it. Delegate out administration, define firewall client settings, server revocation, security policies, intrusion detection. So that was the ISA Server Management Console. And we'll be spending a lot of time in there, so you'll get a lot of experience on that. Let's move on to the importance of Windows Active Directory. The importance of Windows Active Directory when it comes to ISA is to authenticate users and groups to web resources and VPN. So what that means is, say I'm a client, I'm connecting to the ISA server to go out to a website. The ISA server can authenticate me based on my Windows Active Directory username and password, which many cases is the username and password that I already logged on to that client with. And ISA can take that and pass that to the ISA server. Actually, Internet Explorer can take that, pass that to the ISA server when I'm requesting that website, and ISA can use that, connect to the Windows domain controller, verify that I am really who I said I was, and using the rules or the firewall policies on ISA can take my username and determine what websites am I able to connect to. If it's determined I can connect to that website, I'm given the web page, and then logging is done. So my username is taken and put in the log that shows that I went to that website. So authenticate users and groups to web resources. You can also use groups. So I could say these are the people who can access the XYZ website on the internet. You can also use ISA to authenticate VPN. So I'm a salesman, I'm traveling, I'm in a hotel, I connect using VPN back to the ISA server, I type in my Windows username and password, and ISA takes that, authenticates me to the domain controller, and allows me to connect to VPN. So a number of uses there for Windows Active Directory. It also allows for easier management, meaning, by default, only the administrator can manage the ISA server, but you can delegate administration and you can say, okay, this is the ISA administrator group. You can make some group in Windows Active Directory and put whatever users you want to in there and delegate management to just certain Windows users. So that's handy. ISA supports integrated Windows authentication. Now, integrated Windows authentication is what I was talking about. You're using Internet Explorer, let's say, and you try to connect to a website. Internet Explorer can take those credentials that you already logged in with and pass them over to ISA. Now, a lot of firewalls don't support integrated Windows authentication. I know from personal experience, trying to find other firewalls that do support this, it's pretty hard to find. A lot of firewalls support radius authentication, and my point here is that radius authentication is not the same as integrated Windows authentication, meaning with radius, you can tell a firewall to contact a radius server. A radius server is just an authentication server. Usually that authentication server would be told to go to the Windows Active Directory. So when a user connects to a firewall that's doing radius authentication to gain access to the internet and to log requests to the internet, that firewall will request the user's username and password, but they have to type it in again. So even if they're already logged on to their Windows PC, to the domain, they're using their Windows credentials, but they connect to this firewall that's doing radius authentication, they're going to have to log in a second time. And then that firewall connects to the radius server talks to the Active Directory server and authenticates them, and then they're allowed internet access. Well, that's great, but you don't want to have users logging in a second time to gain internet access. So with ISA, you don't have to do that. You have integrated Windows authentication. You also have the firewall client. The firewall client can take your Windows credentials and allow you to run other applications other than Internet Explorer. So with the firewall client, you have integrated Windows authentication. You can go and run FTP from DOS. You can run ping. Whatever it is you want to run, the firewall client knows who you are, tells the ISA server, and allows your access based on the firewall rules and your Windows username. So this Windows Active Directory integration is unique in a firewall. And really, to me, it makes perfect sense. I mean, you don't want to have users log in a second time. So if you're not authenticating users on a firewall with Active Directory usernames, then you're really just left to authenticate them with IP addresses. So IP addresses, you don't want to have to put a static IP address on everybody's PC and say, well, only Joe's PC can access the internet, and only Sally's PC can access FTP, and only John's PC can do instant messaging. You don't want to break down security based on what PC. I mean, if that's the case, then Sally might go to John's PC so she can use instant messaging. Or somebody might change their IP address to match John's PC so they can do instant messaging. So it doesn't really make sense to me to do it any other way than by username. That really provides the granular control that's required. With ISA, you can say, well, only Sally can access this website, and John can never access this other website. So it provides such a granular level of control that a network administrator really needs on the network. Let's move on to remote management of ISA. Now there's two ways to remotely manage ISA. One is using MMC, although let me point out you cannot just use the regular Microsoft MMC when you go in there and add a snap-in like most Windows administrators would be used to. There isn't a snap-in for ISA. You actually have to install the ISA Management Console, which does use MMC. It looks just like MMC, but you actually have to install it from the ISA installation CD. So one way is MMC, and you can do that remotely, and we're going to learn how to do that here in just a second. The next one is Terminal Services Client, which uses RDP, Remote Desktop Protocol. Now that's what we're using right here. That's what this is. This is the Terminal Services Client using Remote Desktop Protocol. And I launched that by going right here to Remote Desktop. Of course, you can find it in the Start menu, but this is great for managing, any Windows server connecting to the server. And then, of course, once I'm here, I'm running the ISA Management Console. So what we're about to demonstrate is how you can run this ISA Management Console on your own PC and connect directly to the ISA server without using a remote desktop protocol. So let's point out that ISA does offer delegation of administration, meaning you can set up a group and you can say this is the ISA administrator group and put users in there, and you can delegate out that administration so you don't have to give someone the administrator, the domain administrator password to administer ISA. Now, the remote management IP address station is configured in a system policy at time of installation if you installed ISA using the terminal services client. So if you connected to the ISA server using the terminal services client and then you installed ISA, the computer you connected from is set up as the remote management station. At that point, that's the only station that can manage the ISA server remotely. To add more systems, you change the remote management computer group, and I'm going to show you how to do that. So here's a little checklist for remote management of ISA. First one is you have to add the IP to the remote management group. So let's say that you want to add a new computer to be able to manage ISA. First, add it to the remote management group. Make sure that the terminal services RDP or MMC is enabled on the ISA server, and then make sure that you have permission on the server to create a terminal services connection. And this is allow logon through terminal services in the local security policy of the ISA server. So let's go look at some of these things. First one is add the IP to the remote management group. I'm going to go over here to ISA, and I'm going to go to firewall policy, and let's go to toolbox and network objects and computer sets. Right here is the remote management computer group. I'm going to double click on that, and you see right now this is the only computer that can manage ISA. You see the description, computers allowed to manage ISA server remotely. So you would click add here. You would add a new computer. You could even add an address range or an entire subnet. So say everybody on the internal subnet or everybody in the IS department, if you want to add some sort of address range maybe, could manage the ISA server. So that's one way, or that's the first thing on our checklist, is to add the IP to that group. Okay, second thing is terminal services RDP or MMC must be enabled. To show that, let's go to task right here. Go to system policy task, and we're going to say show system policy rules. Now, a system policy really is a firewall policy, but by default it's not shown in this list. So when I click this, suddenly we're going to have about 100 system policies listed in the ISA firewall policy list right here. So let me get rid of this taskbar so we can see. So what we're looking for is the remote management, and here it is right here, policy number 2. I'm going to double click on that, and okay, here we go. Remote management. So Microsoft Management Console needs to be enabled, and it is by default. That's that checkbox right there. If we click on the from, it says remote management computer, so it points to this group. You could put in exceptions, you could add individual computers, whatever you wanted to do, but this enables Microsoft Management Console, and this is on by default. Now here's terminal server. Terminal server is on by default, and here's the from right here, remote management computers. So really all you need to do is add the computer to the remote management computers, but keep in mind, if you have some problems, this is what turns it on for Microsoft Management Console and terminal services. I'm going to click cancel on that. And then the third thing is permission on the server to create a terminal services connection, which is allow logon through the terminal services local security policy. Let's go back to ISA. I'm going to minimize the ISA Management Console. And to look at this, we're going to have to go to Administrative Tools, and local security policy right here. So the policy we're looking for is allow logon through terminal services. This policy right here. And by default, administrators and remote desktop users have permission to do this. But if you gave permission to, John Smith to connect or to manage the ISA server over in the ISA management console, you gave permission to his PC, and say you delegated out administration to him. Well, he doesn't have permission to connect as he's not a member of one of these groups, so you'd have to add John Smith here. So that's just something to keep in mind. And then we talked about delegating administration. If we go to the general section here, here's the administration delegation wizard is what this is. So basically it goes through and it asks you, okay, who do you want to delegate administration out to? So you could add in John Smith here. You could add in a group you created called ISA, administration group. So that's how you would delegate out the administration of the ISA server to someone else other than administrator. Now I want to demonstrate how you can use the remote ISA management console, install it on a PC, and then connect to the ISA server directly and manage the ISA server in that method without using the terminal services client or being on the server console. So to do that, I'm going to minimize our slides. I'm going to go to remote desktop, and we're going to connect to our client 1 computer where we're going to install the ISA management console. So I'm going to connect. And notice I'm logging on as the domain administrator. That's important because if you were just logging on as yourself, you would have to delegate out administration to yourself so you have permission to connect. But we're logging on as domain admin. There is another method. Say you log on as yourself. When you connect using the MMC, you can type in the administrator password at that point. So there's a couple different ways to do this. Now, to install this, what I've done is I've taken the exact same CD I had with the ISA installation for ISA Server 2004. I've taken that and I've extracted those files, just as we did when we installed ISA Server, to the local C drive. And then after that, it popped up the Install ISA Server window here. So this looks just like we're installing ISA Server. In fact, we're going to click on Install ISA Server 2004. Now what it's going to tell us is, hey, this is a Windows XP machine. You can't install ISA Server on a Windows XP machine, which is true. But it will allow us to install the ISA Management Console. So we'll accept the terms. We'll take the default there. It says this software cannot be installed on this version of Windows. That's fine. So the only thing we can install right here is ISA Server Management. Enables you to use the management console to centrally manage the ISA server. Requires 22 megabytes on your hard drive. That's exactly what we want. So I'm going to say next and install. So this will take a couple minutes to install. Once it's installed, you'll see that running this ISA Management Console on a Windows XP machine is just like running it on the server console or through remote desktop. It's the exact same program. So while that installs, let's minimize this and let it finish. Let's go back to our slides for just a second. I wanted to point out that once we complete the installation of the ISA Server Management Console, the MMC, we're going to have to go in and add the IP for this remote management station to the remote management group. That should be the only thing we have to do. We're not delegating out administration to anyone else. Administrator is going to be the login we're using to manage the ISA server, and we already know that MMC is enabled on the ISA server. So we're just going to have to add the IP of client 1 to the remote management group. So let's go back and check on the installation, and the installation has completed. Let's go ahead and check the checkbox here. It says invoke the ISA server management when the wizard closes. So it'll just start it for us automatically. Say finish. Okay, this security window pops up here. I'm going to close that. And this is our management console. So to connect to an ISA server, I'm going to right click on this and click connect to. Now it asks for the name of the ISA server. I'll type in ISA bluecrabfood.com, and it says, do you want to connect using the credentials of the logged on user, which we're going to because we're logged on as domain administrator, or use other credentials. So say we logged on as John Doe, we could connect using other credentials and just type in the username and password of the domain administrator. Now before we connect, we need to go in and add our IP address as a management station on the ISA server. So I'm going to minimize this. Let's go over to the ISA server. We'll go into firewall policy, and let's get our taskbar back over here, our task pane, and go down, or go to toolbox, and then on the remote management computers right here, I'm going to double click that. I'm going to click add computer, and this will be client 1, and the IP address will be 192.168.1.12. That's the IP address for client 1. And for description, we'll put allow client 1 to manage ISA server. I'll say OK. And we've added client 1. There's the IP address. Let's say OK. We're going to apply our changes. Changes were successfully applied. I'll say OK. And then we'll minimize this, and let's go back to client 1. So we put in the name of the server. We're going to connect using the credentials we're logged in with, domain administrator. I'll click OK. And here we go. We have an ISA server up here. I'm going to expand that, expand configuration. So now we're monitoring our ISA server over the network using the Microsoft ISA Remote Management Console. We can go to monitoring. Notice there's a little bit more of a delay than there was using the console directly on the server, but hey, it works great. Here's our firewall policies. So we've got that working. That works good. Let's minimize this. So we've learned how to use the remote management MMC, the Microsoft ISA Remote Management Console. We installed that on a client and learned how to add that client PC to the remote management group. With that, let's move on to concepts. So in ISA server, in the management console, two concepts I want to point out. One is the console tree and the task pane. Okay, if we go back here to ISA, the console tree is this area over here. So when I say go to the console tree, this is the console tree in the Microsoft MMC. When I say go to the task pane, this is the task pane over here. Doesn't necessarily mean you're on the task tab. Just anything that's over here, this is called the task pane. So if you go up to view, you can uncheck task pane and that goes away. You can put it back on and it comes back. This over here, the console tree, if I go to customize, I can remove the console tree and that section on the left goes away. So that's what the console tree and the task pane are. Okay, firewall policy. A firewall policy is made up of access rules. So let's go to the firewall policy section here. Okay, we're in firewall policy. Let's get rid of our system policies. Okay, a firewall policy is made up of access rules. So each of these lines here, as we add new access rules using create new access rule, we're creating access rules that are in the firewall policy section. Okay, and then there's system policies. So we talked about the difference between a just regular firewall policy, which is like this one right here. This is the only one we have. This is the default firewall policy. And then there's system policies. So system policies are rules that are created to allow or deny access to the ISA server directly. Firewall policies, these over here, are rules that are created to allow access through the ISA server. So primarily you're going to be making rules to allow access through the server, not access directly to the server. And that's an important difference between a regular firewall policy and a system policy. Okay, we talked about how all traffic is denied unless otherwise permitted, and let's point out that order is important. So let's go back here to firewall policy. Okay, right now this is the last rule. It's always going to be the last rule, and it's default. And the default is to deny all traffic, any protocol, from any network to any network for all users. So the last rule is always to deny everything. So if it's not explicitly permitted in the list above that deny rule, then it's denied at the end. Okay, also order is important. This little first column right here is the order. So when you add a new rule, it's going to be like rule 1, 2, 3. They're going to have numbers. And the last rule will always be this rule. So say I added rule number 1 that says to deny HTTP for everyone. Then I added rule number 2 that says to permit HTTP for everyone. Well, the end result is HTTP is going to be denied for everyone because rule number 1 was to deny it. So the rules are processed in the order that they are created, or the order that they're listed here, and whenever some traffic matches a rule, the processing for that traffic is stopped. So when it hits the first rule that says it's permitted, regardless if the second rule was to deny it. So you have to keep in mind the order and have to keep in mind what conflicting rules will do here. Whatever rule is found first is going to be the rule that's actually applied. Okay, the response to traffic that is allowed out is allowed back in. So ISA is a stateful packet inspection firewall. It knows that some traffic went out and it knows where it went to. So when the response comes back, it's going to allow that response back in because the initial request went out. Now it's not going to just allow traffic in if no request originally went out. So you don't have to create rules to allow traffic back in. You only have to create rules to allow traffic out, and the response will naturally come back in. Now there are some protocols that you have to be careful with, but in general that's how it works. Okay, access rule elements. The elements of an access rule under a firewall policy are protocol, user set, content type, schedule, network objects like networks, computers, domain, or URLs. So let's look over here in ISA. So even with the default rule here, you have an action to either allow or deny something. You have protocols. So protocols might be like HTTP, FTP, SMTP. You have from and to. These from and to, besides saying all networks, you could specify specific networks on the server, or these could even be computers. They could be domains like trainsignal.com. They could be specific IP addresses. They could be subnets. They could be URLs even. So, www.trainsignal.com might be allowed, whereas ftp.trainsignal.com might be denied. So these are the different elements that make up these rules. And when you create a new rule, it's going to go through and ask you every one of these elements. It's very easy to create new rules on ISA because the wizard where it asks you the rules is just so simple. It leads you right through it. It's not like creating a rule on a PIX firewall where you have to know the exact syntax to type in. And keep in mind, another thing that's unique here is you can specify users, whereas say on a Cisco PIX firewall, you're not going to be able to specify Active Directory users. Okay, so we learned about some ISA server concepts here. Let's move on to hardening the default ISA server installation. Locking down and hardening the security of your internet firewall is crucial. The ISA server will protect the entire Blue Crab Food Company network from anything the internet can throw at it. ISA is a very secure firewall out of the box. However, there's always more that can be done to make it more secure. Microsoft offers a great security hardening guide for ISA server available at this URL here. Now, we took one of the steps toward hardening our ISA server by applying the ISA Server 2004 Service Pack 1. So that's a great way to increase the security on the ISA server, is apply the service pack that fixes the bugs, in the server. One of the things that Microsoft recommends to harden your ISA server is to apply updates promptly. Usually those are updates to the Windows operating system. You also have to be careful with those updates to make sure that they don't mess up your ISA server somehow. When you're installing a brand new ISA server, of course you want to apply all those updates and patches prior to installing ISA. With Windows 2003, you do have the automatic update function, so it can go out to Microsoft and pull down patches and apply those whenever you schedule it to. However, some of those patches could require reboots, and you don't want to reboot your ISA server necessarily, without an administrator monitoring that server to make sure it comes back up properly. Another thing you can do is physically secure your ISA server. So put it in a locked room or a data center with security cameras and card key access. So you want to physically secure that server to make sure someone doesn't get to the console so that they could potentially make changes. You can harden the Windows infrastructure by applying the recommendations in the Windows 2003 Server Security Guide. Now, Microsoft recommends that you apply the baseline security policy template, but not the IPsec filters or the server role policies. I would consider applying those types of policies, an advanced ISA task, and not something you want to do, when you're just getting used to ISA, or if you have a server that you've just put in. I would use it for a while, make sure everything works. I would get a good backup of the server before you apply any sort of policy templates like that. In fact, I know many production shops don't apply those security policy templates because they can, in fact, mess up how the ISA application works. But if you're interested in hardening your ISA server, I would recommend going to the Microsoft website and reading more on the ISA server security hardening guide. In conclusion, we learned about ISA server concepts and features. We learned how ISA server is a firewall, how no traffic is allowed in or out by default. We learned about initial configuration of the ISA server and how that depends a lot on what you're going to be using ISA for. We learned that most of the time you'll be configuring firewall policies. That's the most common thing you'll do on an ISA server. We learned how to manage the ISA server, how you can do it with the MMC, the ISA Server Management Console. We learned how you can do it with the Terminal Services Client using RDP. We learned the importance of Windows Active Directory and how the Active Directory integrates into ISA and how important that is to the ISA server and how it makes ISA unique from many other firewalls. We learned how to perform remote management of ISA. We installed the ISA Server Console on a Windows XP client, and we used that client to remotely manage the ISA server. And then we talked about how to harden the ISA server install and increase the security of ISA. This is the end of the video. I hope you learned a lot. Thank you very much.